Hi friends, now we will be discussing the previous GATE questions with respect to chapter 2 of control system named as feedback characteristics of control system. So we have dealt with this theory topic and we have did many practice questions based on this. Now we will be discussing the previous questions that was asked with respect to this topic. Now moving into question number 1. Question number 1. The unit impulse response of a unit feedback control system. The unit impulse response of a unit feedback control system is given by Ct is equal to minus t e raised to minus t plus 2 e raised to minus t for t greater than 0. The open loop transfer function is equal to is what is the question. So the unit impulse response of a unit feedback control system is given. So you already know that it is very easy for us to obtain the transfer function if the impulse response of the system is given, because you can see the Laplace transform of the impulse response is the closed loop transfer function of the system. Okay, so what is asked, we will have to find out the open loop transfer function of the system. So first we will find out the closed loop transfer function of the system. So our expression is given as minus t e raised to minus t plus 2 e raised to minus t. So we are going to take the Laplace transform of minus t e raised to minus t plus 2 e raised to minus t, and then we obtain the closed loop transfer function as minus 1 divided by s plus 1 the whole square plus 2 divided by s plus 1. So combining this expression, it becomes equal to closed loop transfer function is equal to 2s plus 1 divided by s plus 1 the whole square. So what is our closed loop transfer function? The closed loop transfer function is obtained as 2s plus 1 divided by s plus 1 the whole square. Now what is the relationship between closed loop transfer function and open loop transfer function? Closed loop transfer function is actually y of s divided by r of s, y of s divided by r of s, which is equal to g of s divided by 1 plus g of s h of s, isn't it? G of s divided by 1 plus g of s h of s, where h of s is the feedback function, and what is the open loop transfer function? Open loop transfer function is g of s. So we will have to find out the value of g of s. So we can also write it as g of s divided by 1 plus g of s. Okay. So what is closed loop transfer function? It is equal to open loop transfer function divided by 1 plus open loop transfer function when h of s is equal to 1. Okay, so closed loop transfer function can be written to be g of s divided by 1 plus g of s when h of s is equal to 1, or you can write g of s is equal to closed loop transfer function divided by 1 minus closed loop transfer function. So these expressions you have to put it in the box. So if you have the open loop transfer function, then your closed loop transfer function is g of s divided by 1 plus g of s at h of s is equal to 1. And when you have the closed loop transfer function, then your open loop transfer function will be closed loop transfer function divided by 1 minus closed loop transfer function at h of s is equal to 1. Okay, so we have already obtained the closed loop transfer function. So on putting the value of closed loop transfer function into this as 2s plus 1 divided by s plus 1 the whole square, we will be getting g of s as 2s plus 1 divided by s square. So 2s plus 1 divided by s square is our answer. So option B will be our answer. So 2s plus 1 divided by s square is the answer for question number 1. Moving into question number 2. Feedback control systems are insensitive to both forward and feedback parameter changes. Less sensitive to feedback parameter changes than to forward path parameter changes. Less sensitive to forward path parameter changes than to feedback parameter changes. Equally sensitive to forward and feedback path parameter changes. So this is a portion that we have already discussed while we were discussing the theory portions. We have already made expressions with respect to sensitivity of the feedback system with respect to the feedback path. So SG transfer function, the transfer function of the system is 1 divided by 1 plus GH, and then the sensitivity of the transfer function, the closed loop transfer function is g of s divided by 1 plus g of s h of s, isn't it? 1 plus g of s h of s. And then what is the sensitivity? Sensitivity of the transfer function is 1 divided by 1 plus GH, and the mode of the this is the sensitivity with respect to the forward path, and this is the sensitivity with respect to the feedback path. Because what is the gain with respect to the forward path? The gain with respect to the forward path is G of S. So it is Sg sensitivity of the forward path of the transfer function. So it is 1 divided by 1 plus GH, and if H of S is the feedback path gain, then the feedback path gain of the transfer function with respect to H will be equal to GH divided by 1 plus GH. 1 plus GH. So it is less sensitive to change in G than change in H. So that means the system is always more sensitive to the feedback path than the forward path. So what will be our answer? Our answer will be less sensitive to forward path, and it will be more sensitive to the feedback path parameter changes. So you will have to study this once again. Our answer for question number 2 is option C. It is option C, because the system is always highly sensitive to forward path parameter changes, and it is less sensitive to forward path parameter changes, and it is highly sensitive to feedback path parameter changes. So while we were discussing the theory, I reminded that you will have to design the feedback path really accurately, and you will have to design the feedback path elements with care, and you will have to also provide insulation or isolation to the feedback path, the feedback loop that we are providing to the system, because the system is extremely sensitive to the feedback path parameter variations. Okay. Moving into question number 3. As shown in the figure, a negative feedback system has an amplifier of gain 100 with a plus or minus 10% tolerance in the forward path, and an attenuator of value 9 divided by 100 in the forward path. The overall system gain is approximately is what is the question. So as shown in the figure, a negative feedback system has an amplifier with a gain 100 with a plus or minus 10% tolerance in the forward path, and then an attenuator of value 9 divided by 100 in the feedback path. So the overall system gain is approximately is to be found out. So we will have to find out the overall system gain. So the forward path is 100 plus or minus 10%. It becomes G. So what is variation of G? Variation of G is 10%. So that means it is 10% or 0.1. H is given as 9 divided by 100. 9 divided by 100. So what is the overall gain? Overall gain is G divided by 1 plus GH. G divided by 1 plus GH. What is G? G is equal to 100, and 1 plus divided by 1 plus GH becomes equal to 1 plus 100 into 9 by 100, which becomes equal to 10. Okay. So what is our sensitivity? Our sensitivity with respect to G is 10%. Okay. So it is 1 divided by 1 plus G, 1 plus T. It is 1 divided by 1 plus 10 into 1 into 10%. Or what is the overall sensitivity of the system? The overall sensitivity of the system will be 1%. See here, what is G given? G is given as 100 plus or minus 10%. So rewriting 100 plus or minus 10% as G, we see the variation of G is 10% or 0.1. Okay. And H is given as 9 by 100. So we can directly substitute the value of H and G, and then we will obtain the overall gain of the system as 10. Okay. So the overall gain of the system is obtained as 10. So that means overall gain G of the system is equal to 10. And what is H? H is then equal to 1. So 1 divided by 1 plus 10 into 1 into 10% variation. Into 10% variation means 10 divided by 11, and it becomes equal to 1%. Okay. So it becomes equal to 1%. So what is the overall sensitivity with respect to G? Overall sensitivity with respect to G is 1% for the given system. So it is 10 plus or minus 1%. So option A will be our answer for question number 3. Now moving into question number 4. The open loop transfer function for a DC motor is given as omega of S divided by VA equals 10 divided by 1 plus 10s. Okay. When connected in the feedback as shown below, the approximate value of Ka that will reduce the time constant of the closed loop system by 100 times as compared to that of the open loop system is what is the question. So these questions are very good questions. This is a 2-mark question for 2013 examination. Okay. So the open loop transfer function of a DC motor is given by 10 divided by 1 plus 10s, and it is connected in a feedback system as shown below. Approximate value of Ka that will reduce the time constant of the closed loop system by 100th times as compared to that of the open loop system is what is the question. So we are making the expression of omega of s divided by Va of s. Okay, so what is omega of s divided by Va of s? It is 10 divided by 1 plus 10s. Okay, so it becomes equal to 10 divided by 1 plus 10s, where it can be written to be in the form of K divided by 1 plus tau s. Okay, so where tau becomes equal to 10. So we have obtained tau as 10. So if it is a closed loop system, then what is omega of s divided by R of s? Omega of s divided by R of s. What is the total forward path transfer function? It is Ka into 10 divided by 1 plus 10s. Okay, so it is Ka into 10 divided by 1 plus 10s divided by 1 plus 10 Ka divided by 1 plus 10s into HFS, where HFS is equal to 1. So it is a unity feedback system that is shown where HFS is equal to 1. So HFS is equal to 1, not 0, HFS is equal to 1. So HFS is equal to 1. So here HFS is equal to 1. So it becomes 10 Ka divided by 1 plus 10s divided by 1 plus 10 Ka divided by 1 plus 10s, which gets reduced to 10 Ka divided by 1 plus 10 Ka plus 10s. So continuing with our discussion for this question. Now omega we have obtained as omega s divided by R of s equals 10 Ka divided by 1 plus 10s divided by 1 plus 10 Ka divided by 1 plus 10s. So solving this expression, you will be getting it as 10 Ka divided by 1 plus 10 Ka plus 10s. Now what we are doing is that we are going to divide the numerator and the denominator with the 1 plus 10 Ka. So dividing the numerator and the denominator with the 1 plus 10 Ka, you will get this expression as 10 Ka divided by 1 plus 10 Ka, the whole divided by 1 plus 10 divided by 1 plus 10 Ka into s. So we have obtained the expression in this format, and from the question it is said that for the open loop transfer function of the system 10 divided by 1 plus 10s, we have to find the approximate value of Ka that will reduce the time constant of the closed loop system by 100ths as compared to that of the open loop system. So what is the transfer function for the open loop system? The transfer function for the open loop system is 10 divided by 1 plus 10s. So it is 10 divided by 1 plus 10 Ka. So it has to be reduced to 1 by hundredths of the gain of the open loop transfer function. What is the gain of the open loop transfer function? It is obtained as tau is equal to 10. So it is 1 divided by 100 into 10. So 1 plus 10 Ka, 10 and 10 will cancel. So 1 plus 10 Ka becomes equal to 100, or Ka becomes equal to 9.9. So it is 9.9, approximately 10, and then our option will be C, which is 10 for question number 4. Now moving into question number 5. The closed loop transfer function of a system is given as T of s is equal to 4 divided by s square plus 0.4s plus 4. The steady state error due to unit step input is to be found out. Steady state error unit step input means R of s is equal to 1 by s. So we will have to find out the value of ESS in this question. So the closed loop transfer function is given. We will have to convert the closed loop transfer function into open loop, corresponding open loop transfer function. So you know how to convert a closed loop transfer function into open loop transfer function. How to convert a closed loop transfer function into an open loop transfer function? What is the corresponding equation? If you have the closed loop transfer function, what is the corresponding open loop transfer function? Closed loop transfer function, G of s is equal to closed loop transfer function the whole divided by 1 minus closed loop transfer function. So we have the closed loop transfer function here, and what is the closed loop transfer function? It is T of s is equal to 4 divided by s square plus 0.4s plus 4, and utilizing the expression of closed loop transfer function divided by 1 minus closed loop transfer function, you will be able to find out the open loop transfer function g of s of the system. Now this is the open loop transfer function g of s, and what is g of s? G of s is equal to 4 divided by s into s plus 0.4. And what is the input that we are giving? We are giving the input as r of s is equal to 1 by s, because we are giving a unit step input into the system. Now when you are finding the steady state error, you know the equation for steady state error is ESS is equal to limit s tends to 0 s r of s divided by 1 plus g of s h of s. So ESS is equal to limit s tends to 0 s r of s divided by 1 plus g of s h of s. And when h of s is equal to 0, that is for a unity feedback system, our expression becomes limit s tends to 0 s r of s divided by 1 plus g of s. Now what is r of s? R of s is equal to 1 by s, and what is g of s? It is 4 divided by s into s plus 0.4. So limit s tends to 0, and substituting the values, when you are applying limit s tends to 0, the steady state error ESS becomes equal to 0. So what is our answer? The closed loop transfer function of the system, the steady state error due to unit step input is 0. So for question number 5, our answer is 0. Now moving into question number 6. The block diagram of a system is shown in figure. So this is the block diagram that is given. It's a simple block diagram that is given. The desired transfer function of the system, g of s, c of s divided by r of s is equal to s divided by s square plus s plus 1. Then what is the value of g of s is what is the question. And in the figure you can see this is g of s. Okay. That is the block of g of s. So 4 options are given. You will have to substitute the values. Okay. So when you are substituting different choices for g of s, you will see that g of s is equal to s will give you the transfer function. C of s divided by r of s is equal to s divided by s square plus s plus 1. So for question number 6, we will go with option B, and then the value of g of s will be equal to s. So this is all about the questions dealing with this chapter. So you have to study all the theory portions. You have to work out all the previous all the practice questions, and here are the previous questions that is asked for various GATE examinations from this chapter.